Let's have a new topic like Laplace transform of system of differential equation. We have a system two equation with two unknown, and these are differential equation because the derivatives are there. Two equation, two unknown, we are solving using Laplace transform. Let me call it 1, let me call it 2, and solution. I am taking the Laplace transform of equation 1 and 2 and simplifying, and then you using Cramer rule. The best idea is, if you are solving the system, the better is to Cramer rule. Taking Laplace transform of equation 1 and equation 2. Laplace transform. So Laplace transform of y1 dash minus Laplace transform of y is equal to 0. Then Laplace transform of y1 plus Laplace transform of y2 dash is equal to twice Laplace transform of cos t. So Laplace transform of the first derivative we know as capital Y1 minus Y10 minus this is Y2. Capital Y2 is equal to 0. Then this is capital Y1. After taking the Laplace, it is a function of S. Then Laplace transform of y2 minus y20 is equal to 2s over s square plus 1, which is Laplace transform of cos t. y10 is 1, putting 1 here. So sy1 minus 1 minus y2 equal to 0. y20 is 0, so put 0 there. So this is y1 plus, this is plus sy2 0 equal to 2s over s square plus 1. Let me simplify. sy1 minus y2 is equal to 1. This minus 1 I am taking there. Then y1, there is y1 there, plus sy2 here is equal to 2s over s square plus 1. So I have arranged y1, there is y1 there, and under y2 there is y2 there. I am using Cramer rule now. Using Cramer's rule. And in Cramer rule, I have the idea ax plus by is equal to c1, a1x plus b1y is c2. If I am using the Cramer rule for linear system of equation, I will have x. X is going to be replacing the coefficient of x by the right hand side. c1, c2, and this is b, b1, and this is a, b, a1, b1. 2 by 2 determinants. Expand this, solve this, and solve this, dividing, you are getting x. Similarly for y. For y, you are a1 as it is. Coefficient of y is replacing by the right hand side. c1, c2, there is a, b, a1, b1. Solve the determinants of 2 by 2 in the numerator and denominator, you are getting x and y. So these are Cramer rule. Let me apply the Cramer rule over here, and I am applying the Cramer rule for y1. So this is 1, 2s over s square plus 1, and this is minus 1 and s, and this is s minus 1, 1 and s. Look at that, the coefficient matrix, and when I am finding y1, the coefficient of y1 is replaced with the right hand. Then put a negative sign, multiply this with this, which is minus minus plus 2s, this is s square plus 1, and divided by s square plus 1. This implies y1 is s into s square plus 1 plus 2s over s square plus 1 whole square. So I have taken the LCM and solving like this. So it could be s over s square plus 1. This is divided by this. So 1 s square plus 1 is cancelled plus 2s over s square plus 1 whole square. So this is the thing. And if you are taking Laplace inverse, you are getting, now taking Laplace inverse, taking inverse Laplace transform. So taking inverse Laplace transform, y1 is equal to Laplace inverse s over s square plus 1 plus Laplace inverse 2s s square plus 1 whole square. Look at that. Now we have studied convolution. This is going to be cos t. This is going to be cos t. For this we have to calculate separately. Let hs is equal to 2s s square plus 1 into 1 over s square plus 1 using convolution. I am using convolution. So let f of s is 2s s square plus 1. Let g of s is equal to 1 over s square plus 1. So you can have this. It means f of t is equal to 2 cos t. It means g of t is sin t. F of tau is equal to 2 cos tau. G of t minus tau is sin t minus tau. So you can have f of tau, g of t minus tau. Now we are using the convolution. So h of t is equal to f convol g upon d, which is by definition 0 to t f of tau gt minus tau d tau. So putting the values 0 to t 2 sin t minus tau cos tau d tau. 2 sin a cos b. Now 2 sin a cos b, 2 sin a cos b is sin a plus b plus sin a minus b. 2 sin a cos b is this. So I am using this. So 0 to t sin a plus b. This is my a, this is b. Sin a plus b. T minus tau plus tau plus sin a minus b. T minus tau and d tau is there. So this is 0 to t sin tau goes t plus sin t minus 2 tau and d tau with each t tau. So h of t, which is the Laplace inverse, let me separate the integral. Sin t is there 0 to t d tau. Because this is constant, I have taken, and d tau is there 0 to t. Plus 0 to t sin t minus 2 tau d tau. This is going to be, let me integrate. Sin t here tau 0 to t minus cos t minus 2 tau over minus 2 0 to t. Integral of sine is minus cos t, and with respect to tau, we are going to have minus 2 there. So here tau is replaced by t sine t, and then 0 is there. Minus minus plus half is there. Tau is replaced by t, cos t minus 2t, minus cos, tau is replaced by 0 t. Cos minus t is cos t, and this become cos t minus cos t. This is half there, this cancelled. So your answer will be t sine t is your h of t. So you are using the convolution to find the inverse Laplace transform of the product of the function. So its answer is t sine t. Its answer is t sine t. This is y1t. So now if you are using the grammar rule for the second, that's okay. If not, then it is simple function. If you differentiate this and putting here, you are getting y2. Let me differentiate. y1 dash is minus sine t plus t cos t, because derivative of t is 1 sine t, and then t is as it is, product rule I am applying to derivative of sine t is cos t. This goes, we are left with t cos t. So it means y1 dash is t cos t. So this implies y2 is equal to y1 dash. y2 is y1 dash, and y1 dash is t cos t. So which is t cos t. So y1t is this, and y2t is t cos t. So sometimes things are very easy. If you are using grammar rule, you can have grammar rule on 1, and then the rest of the variables y2, y3 you can by differentiating or by integrating. System of differential equation using Laplace transform. Let us solve the system. y1 dash is equal to 2y1 plus 4y2, and the other is y2 prime is equal to y1 plus 2y2, and the conditions are given. We are solving this system of two equations of 2 with 2 unknown with the help of Laplace transform. Solution. Taking Laplace transform of equation 1 and 2. So this is Laplace transform of the first derivative is equal to 2 Laplace transform of y1 plus 4 Laplace transform of y2. And the other equation, Laplace transform of y2 prime is equal to Laplace transform of y1 plus 2 times Laplace transform of y2. So this is Laplace transform of the first derivative, and we know that this is sy1 minus y10 is equal to 2 capital Y1 plus 4 capital Y2. Capital Y1 and capital Y2 are function of S. Small y1 and small y2 are function of t. Similarly, sy2 minus y2 at 0 is equal to capital Y1 plus 2 times capital Y2. Putting the initial condition. So sy1 plus 4, because y10 is minus 4, and there is minus there, minus become 4 is equal to 2y1 plus 4y2. Similarly, the other equation sy2 plus 4 is equal to y1 plus 2y2. So to solve the system, it is good to use grammar rule. Let me have y1 first of all, I'll write, then y2, then a constant. Similarly for the second equation, I'll write y1, then y2, then constant. So s minus 2 y1. This y1 I am taking here. Y1 is common. S minus 2 minus 4y2 is equal to minus 4. This y2 I am taking on the left hand side. Similarly, minus y1. This y1 I am taking here plus s minus 2 y2 is equal to minus 4. So this is ready for the grammar rule now. So y1, applying grammar rule. Grammar's rule. Let me have here. y1 is equal to, replacing the coefficient of y1 with the right hand side, which is minus 4 minus 4. And coefficient of y2 is written like this, s minus 2. And here coefficient, determinants of the coefficient matrix, s minus 2 here, minus 4 there, minus 1 and s minus 2. Determinants of 2 by 2 matrix. I multiply this with this, which is minus 4 times s minus 2, and put a minus sign, I'll multiply. Minus 4 is 16 plus 16. And I multiply this with this, which is s minus 2 whole square, put a negative sign, multiply minus 4 with minus 1, which is 4. So this is capital Y1. So at this stage, it is good if you are finding the Laplace inverse here. S minus 2 divided by S minus 2 whole square minus 2 square. Let me write this. And again minus 16. Minus 16 over S minus 2 whole square minus 4 whole square, square root of that. It is ready for the Laplace inverse to be taken. Taking inverse Laplace transform. Inverse Laplace transform. So y1 is d now. Look at that. This is s over s square minus a square, something hyperbolic. So minus 4 cos hyperbolic 2t, but s is replaced by s minus 2 everywhere, s minus 2. It means you have to write down e 2t. This is the formula for cos hyperbolic Laplace transform cos hyperbolic at is s over s square minus a square. But here your s is replaced. So if s is replaced, so you have to multiply with e to t. Then minus, there must be a. It means 4 times 4, 16. So I'll write 4 here and 4 here. So this becomes 4 times e to t sine hyperbolic 2t. This is y1t. This is y1t. This is the formula for sine hyperbolic 2t. And since s is replaced, so you are not going to forget to multiply with e to t. So this is hyperbolic 4t cos 4. This is 2 square. 2 square. 4 means 2 square. So that's okay. Minus 4 e 2t cos hyperbolic 2t minus. So it is going to be 2. A is 2 and here it is 8. 8 times 2. A is 2. So this is 8. 8 e 2t sine hyperbolic 2t. So this is because if you are Laplace transform of sine hyperbolic at, which is a over s square minus a square, and 2 square, mean 2 is there. So 8 times e 2t sine hyperbolic 2t is y1. One thing I would like to discuss here, in the previous question our answer was very small. Suppose it is something cos t, something like that. So what do I suggest is, if you are taking the derivative, putting the value of the derivative here, y1 there, you can find y2 immediately. But here in this question you have seen y1. This is a big function, because here there are two functions, here there are two functions, and if you are taking, if you are taking the derivative, so you have to apply product rule here, putting the values of the derivative, and this, it is quite cumbersome. It's difficult to take the derivative and to work with it. So the best idea is, you have to have a grammar rule for y2. Let's have grammar rule for y2. Grammar rule for y2. Because if I am taking the derivative of y1 to put there to find y2, it's difficult. It's difficult because this is a big function. You have to apply product rule here, then simplifying, then putting the values of the derivative. So sometime you have to make your mind what to do, which is going to be good. So for y2, y1, the coefficient of y1 is written as it is. The coefficient of y2 are replacing by the right hand side. This is what a grammar rule is. Coefficient of y2 is replacing by the right hand side, and in the denominator the coefficient matrix. This is -1 s -2. So y2 is equal to, let me solve, -4 times s -2 -4, and then s -2 whole square, and this is -4 again. If you multiply, this is +4 and this. Let me separate again. This is s -2 over s -2 whole square, -2 square minus 2 times. Here, let me, in a minute I'll do it. 2 square minus 2 square. So this is very good, not to simplify this, not to removing square, because this is already, s is shifted to s -2, in the denominator it is s -2, so it is ready for the Laplace inverse to be taken. So the last step, taking inverse Laplace transform. Taking inverse Laplace transform. So you are getting y2t, which is -4 e2t cos hyperbolic 2t, -2 e2t sin hyperbolic 2t. So this is your y2, and that is y1. We have calculated y1, which is -4 e2t cos hyperbolic 2t minus 8 e2t sin hyperbolic 2t. So this is the solution for y1, y2 for the initial value problem of a system. If you are solving the system, you have to apply grammar rule, which is really feasible, very good. And if you are eliminating, by eliminating the constant something, is really little bit difficult. So grammar rule is wonderful in this case. So if one of the variable, if you are calculating y1 or y2, if it is smaller, then before you are not going to apply grammar rule, you are going to have the derivative, putting there, getting the answer. So similarly, if you have a system of 3 by 3, a 3 equation with 3 unknown, where the 3 conditions are given, y1 0 is something, y2 0 is something, y3, you are going to simplify by taking the Laplace transform. Here you will have 3 equations, capital Y1, Y2 and Y3. So again you are using grammar rule for 1. So you can find either Y1 or Y2 or Y3 using grammar rule, and you are writing something like this, then taking Laplace inverse to getting the value of one of the variable, which is Y1 or Y2. Then you are taking the derivative, putting back, getting the other remaining y2 and y3, because this is very good. But in 3 by 3 matrix, if you are each time you are having the grammar rule, it's really cumbersome, it's little bit